Welcome to this week's MTD podcast. In this podcast, we will be discussing how to get the most out of your fifth axis machine tool and fifth axis strategies using CAM that can help you refine and help the process become even more efficient. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a proud member of the MTD team. And I'm very excited and have the pleasure to be joined by two very special guests. Firstly, Chris Pritchard, Head of Machining at Brafe Engineering Ltd. Chris, with a wealth of experience and knowledge in all areas of manufacturing. And I can't wait to tap into this today, Chris. So welcome yet again to the MTD podcast.
Morning, Gio.
How are you today, Chris?
All right? I'm really, really well, thank you. Yeah, enjoying the sunshine.
Good man. And thanks for the recent visit at Brafe. Now, next up, we have the pleasure to be joined by Ben Miller. Ben is Head Applications Manager for the whole of the UK for SolidCAM. And again, I can't wait to tap into your expertise in this area, Ben. So welcome to the podcast, Ben.
Morning, Gio. Thanks very much.
How are you, Ben? All right?
Yeah, good, thanks. Good. Not much sunshine up north, but we're still good.
Do you find you're driving around again a little bit more?
Yeah, a little bit more. Getting out there a little bit more now. I think people are a bit more receptive to having visitors and things. So yeah, getting out and about. It's nice to be out in the car and get a bit of fresh air rather than being stuck inside, I think.
Yeah, you do a few miles, don't you, Ben? Safe to say.
Yeah, fair few miles. Yeah, covering the whole of the UK and Ireland as well. So we rack up some miles in the year.
Well, great to catch up with you again, chaps. It was an absolutely great visit at Brafe recently, which we had, looking at the titanium valve body for the oil and gas industry. But before we start on this podcast and before we get into the nitty gritty, let's start with you guys, and tell our listeners a little bit about you. Let's start with you this time, Ben. How and why did you get into engineering, and tell us about your position at SolidCAM now and what you actually do?
So I got into engineering when I left school, really. I did an apprenticeship at a local engineering firm and progressed from there. I started off in manufacture and did a little bit of design as well in the design office, and then sort of progressed into CAM in that company. I then sort of moved around a couple of different engineering firms, working on the shop floor, programming machines by hand, and then got into the CAM industry, working for a CAM supplier and working for SolidCAM now. So I'm the applications manager for SolidCAM. I have a team of applications engineers here that we're all out on the road. We're all helping the customers, doing demos, things like that. Got dedicated team of post writers as well for the more complex post processes. That's us really.
It's a brilliant company, not just in the UK but around the world. So it's a massive company. Ben, without your prior experience in engineering, hands-on experience in engineering, would you be able to do the job that you do now?
I think it would be more difficult. CAM, a lot of people sometimes see CAM as if you've got CAM, you can basically program anything. You still do need the skill and the experience of how to actually machine. There's no substitute for that. You can't just ask a computer to know how to cut metal, what tools to use, what strategies to use. So definitely being off the shop floor and coming into the CAM industry is definitely a major advantage. And as is, all of the team here, all of the engineers here, they're all off the shop floor, in a previous life as such. So it definitely gives us an edge.
I agree. I completely agree. Now, Chris, you've got a wealth of experience, and it's quite apparent from kind of meeting you twice at Brafe and some of the kind of processes and process improvements that you've put into place there, and some of the cycle time reductions with the help of companies and the collaboration with some of the OEMs and partners that you're dealing with. But without that wealth of experience, you wouldn't have been able to bring the right people together to achieve the results that you're achieving. So Chris, again, really with you, just to kind of so our listeners can get a bit of an insight into your background and your knowledge. How did you get into engineering? Why? And how did you gain all this experience?
Well, it's exactly the same as Ben, really, where when I left school, I started an apprenticeship at a local engineering firm. I actually started my apprenticeship in sheet metal and fabrication, but that sort of quickly took a turn to the left after I sort of was involved in a car accident. I then couldn't lift anything heavy, so I went on to the CNC machines, where I sort of spent my time there. After sort of the recovery from the injury, I then, very much what Ben said, I learned how to cut metal, but that wasn't on a CNC. That was on the manual machines, working with manual lathes, manual mills, gear cutters, radial drills, the basic stuff. But I learned how to cut metal. And from there, then obviously the opportunities opened up for me to go onto the CNC machines full time, where I'd done more training. I then became deputy of the machine shop. And yeah, just kept on growing and growing from there. And then when I reached a stage there where I felt I couldn't grow anymore, so I decided to leave where I was, and I went into sales of cutting tools for one of the major brands of carbide cutting tools, which really got me out into the world. I got to see all types of machines, how different processes, on how other engineering companies do it, which really, really sort of gave me such a large knowledge of every type of engineering that I wanted to sort of know about and what I wanted to be involved with. And it was just one of those things I really, really enjoyed. The opportunity then came up to move to an engineering company and sort of head up the manufacturing team there, which I sort of took with both hands. With an ever-growing family, life on the road was sort of not taking its toll, but I would have preferred to spend more time at home. So I decided to move back to sort of the office job, or to the workshop sort of job, and took a job as a head of machine company in Norwich. And after 3 years there, I then moved on to where I am now at Brafe Engineering, head of machining there. Again, lovely opportunity to improve all their processes, help develop what they do. For many, many years we've made high-end super alloy castings, and the processes have been old age techniques that are very, very successful, although they needed modernising. And that's where I've then come in. I've invested in the most latest plant with the Grog G350T, the latest work holding with the Shunk S0 work plate, I think it is, and then also with SolidCAM as well.
I mean, yeah, I'm looking forward to touch on all of them elements that you've just mentioned there, and I didn't know about your car crash, so thankfully
it was only it wasn't anything major, but I completely snapped one of my arms, so that just restricted what I could lift and what I couldn't lift. So they said, well, you can sit in front of a CNC for 3 weeks and press buttons, because that's all we do apparently, just press buttons when you're running a machine. So
it's fate, really, then,
Chris. Yeah, it is. Yeah.
I mean, for me, what you've touched upon there, I think that all three of us have got very similar backgrounds in engineering. I've done my apprenticeship as a tool maker. I learnt on manual equipment, lathes, capstans, knee mills, the little milling machines, and effectively, fundamentally, it's the principles of engineering what you're learning on a manual machine, which is invaluable when you come to kind of plan a process on a CNC machine. You know what works, what doesn't work, even to the extent of actually designing a component to make. You know how it can be made, the best way of making it, to leave excess material on the billet, so on and so forth. So without kind of digressing too much, I think that in engineering, you never stop learning. But I think that, in my opinion, I'm definitely a strong believer that from even some of these new engineers coming into engineering now, they still should start off on manual machinery. 100%, absolutely 100%.
Most definitely. The last place I worked, didn't have any manual machines. So their first step, they had to go onto a CNC, and because we were fully sort of automated with CAD, they never even got to learn truly how to program, because it was all done via CAD. CAM. So yeah, they didn't know how to cut metal, and they didn't really know how to program, because it was sort of hand-fed to them. And
they're missing a massive part out of their engineering. Yeah. They're missing a massive part out, and I was the other way around, Chris, to be honest. So I kind of started on the manuals, and I worked my way up into CNC. Then I started programming, but everything that I programmed was on the duck board. I programmed everything into the CNC directly because at the time, CAM didn't really exist, and we weren't even doing 3D work at the time. We didn't really need it. I mean, some of the bits of programming that we did, we had to use trigonometry and Pythagoras, and some of the programs were thousands of lines long, and that was using labels and macros and everything else, and they're still ridiculously long programs. However, that experience, again, it's invaluable. So when you do move on, you've got a real good understanding of what works and what doesn't work, and in my opinion, it's absolutely imperative. And I think that the younger children really do need to kind of realize what benefits that they get from that, and that it will not lead to a dead-end job, but it will probably lead to the very best jobs in engineering.
You sound like you've got quite a lot of qualifications, Joe. You're looking for a job or a change of career at any time. Fancy going back to...
Mate, I wouldn't know where to start anymore, Chris. But let's start now with the podcast in regards to fifth axis machining. Now, in the UK, we've gone mad on fifth axis machines, and to be honest, I feel that some of the fifth axis machines that are out there, full simultaneous, are not really the right machines for the application. A lot of the fifth axis machines out there are just doing 4+1 work, which you could do on a 3-axis with a 4th axis rotary table. But if you are doing some of the complex work, such as you, Chris, how important is it to get the very best out of that fifth axis machine? Now, let's start with you on this one, Ben. People or engineers could kind of quite easily overlook CAM when buying one of the state-of-the-art fifth axis machine tools. But what would you say to them? How important is CAM to get the very best out of that fifth axis machine tool?
Yeah, I would say it is quite important, really, from a point of view of, that machine tool, the 5-axis machine tool is going to cost you, quite a large investment. So you want that machine tool running constantly. You don't want it stopped while somebody stood there programming at the duck board. Yes, you could program it at the duck board in 3+2, 4+1. When it comes to simultaneous 5-axis, you really do need a CAM system to sort of generate those toolpaths for you, especially if you're doing something complicated and you need a good toolpath. But yeah, in terms of sort of 3+2, it's just a 3-axis machine and you're just indexing, and that's what a lot of people see. But as I said, you're stood at the duck board programming that for 2 or 3 hours to get the job going. That's 2 or 3 hours of lost production. So to be able to program it offline and see simulation, fix any issues on the simulation as well before it actually goes to the machine as a proven or semi-proven program as such, I would say that's invaluable, really.
I mean, I get the benefits of that. You keep the spindle turning, and that is, we always refer to that, even with kind of automation and 0 point and palletization. But you're getting other benefits as well. I mean, tell us about iMachining and them strategies. You won't be able to programming strategies such as that. And you educated me, Ben, when we were at Brafe in regards to you can actually tweak the kind of speed of the strategy dependent on the work holding and how securely the part's being held. I mean, there's bits like that kind of, if you had to program them manually, you wouldn't get the same results, would you? So effectively, through them strategies, you're reducing cycle times as well.
Yeah, so iMachining is obviously our intelligent toolpath with the wizard built in. So we're drawing on sort of 30 years of machining experience and built that into iMachining, where we can basically put the data in. So we put the machine tools limits in, its spindle power, things like that. We tell it what tool we're using, so the helix on the tool as well. We tell it what material we're cutting so that it knows the machinability factor of that material. And then it will calculate all its speeds, feeds, depth of cut, step overs automatically. And as you said, we've then got a slider bar. It's the machining level, or what we would like to call the Brafe meter, as Chris will tell you, as to how sort of quickly you want to machine with eye machining. So it's all about rigidity. If we've got the component held nice and strong, you've got a good gripping force on there. It's the machine's quite strong and capable. Good tooling in there, premium carbide. Then we're turning the levels right up, towards the top. We want to be at 6, 7, 8 on the machining level. If you come to something, maybe you're doing a second op and you've not got the part held quite so rigidly, we can wind that machining factor down a little bit. So we might come down to 3, 4, 5, something around those marks. And all that will do is you're still gaining the benefits of eye machining. So we're still using that small step over, high speed and feeds, but it brings all those factors down consistently with each other. So the step over reduces, the feed reduces, and the spindle speed reduces. So you're still gaining that same cutting forces. You're keeping nice light cuts on the tool, steady on the spindle, but we're doing it just a little bit slower. So yeah, we've got all that control inside eye machining, which again I think is a nice little touch. It's okay saying, well, this is an automated strategy and it does everything for you. There's always going to be a need for that, again, going back to that experience of the engineer, of saying, well, actually, I know that this is a little bit too fast, or this is a little bit too aggressive. I'll dial it down a little bit. So we're not taking the control out of the engineer completely. Again, we're letting the engineer make that decision and control those little things that he needs to control, really.
It's very bespoke, that is, and I like that. I think at the end of the day, you're right, Ben, because at the end of the day, the CAD/CAM package doesn't know how you're holding that part for op to. If you're holding a raw casting and you can't hold it properly, how does the CAD/CAM package know that you're not holding it properly? You need to have that knowledge, and that leads us on nicely, really, to all the other elements around the machine, really. Recently, Chris, you invested in a Grob G350T, state-of-the-art fifth axis machine tool, full fifth axis simultaneous, but with turning capability and a horizontal spindle. I love that machine. It's a fantastic bit of kit. But as Ben alluded to, Ben's saying rigidity, but it's about eliminating vibration, completely getting vibration out of that process, and then you can really hit the part hard. How have you achieved that on that machine? Because some of the parts you make, some of these castings that you manufacture as well on site, irregular shaped parts, casting variants, not easy parts to hold, securely.
No, it is a struggle, and the bit you came down to see the other day, we were fortunate in the sense that was a forged titanium block, so that was straight in the vise, clamp it in, and off we go, and that was lovely work holding. We weren't using printed jaws or anything like that. That was just into a milled set of soft jaws, and yet it still performed and still cut, and we were achieving great speeds and feeds. When it comes to all our other work that we do, every part needs a fixture of some sort. Generally, the luxury or the biggest problem we have obviously with the casting is getting that first op right, getting the cores in the casting aligned, finding the true datums of all the features that are on that casting. And that's really that's the key benefit of us having a 5-axis, that we can manipulate the part in any way to run various probing cycles to find that center point. Then from there we can then do a pre-op and hold it on a fixture. For us to be able to have the rigidity, we went with the shunt work holding, so that we've got full flexibility to take parts off. We've got a chuck, we've got a vise, we've got fixture plates that we just bolt the stud straight to the bottom. We throw it on, clamp in any position. It repeats within a few microns every time. And then the next step with that was to have the CAM package to finish the whole setup off, which allows us then to seamlessly program each operation that we have for the parts, which as a package with the Grob, the shunt and the SolidCAM, it all works nicely as a package. So.
And you mentioned with the casting. Now, I don't know how accurately your castings are, but with castings, you always get casting variants. They're never all exactly the same, and this can really kind of be problematic when holding one casting from another. But not only that, it throws out your datum point, because if the size of the casting changes, then if you're working from a fixed jaw, then your datum point will move. So you mentioned probing. So are you probing everyone to redatum each casting before you start machining it?
Just to align the cores for the first off. Yeah. It's a key thing of what we do. And like I say, it's funny because we're probably one of the worst, because we have got a 5-axis machine that we don't do a great deal of 5-axis machining on, but for the product that we make and the manipulation we need to make our product, the 5-axis works wonders for us.
And some of the materials as well, kind of, that you're machining, Chris, can you tell us about them?
None of them are nice. They're all it's all high alloy, super alloy steels, Inconels, Hastelloys, super duplexes, titaniums, and all of these materials that we have, they all benefit from the SolidCAM eye machining, because everything gives us a benefit. It's always such a softer cut on the workpiece. And sometimes when we're holding a casting down with a couple of small bolts to a fixture, you need to have a nice, smooth cutting contour that's not gouging in, it's not digging out in corners, and the eye machine offers itself perfectly for that.
So can you explain that in a little bit more detail? So kind of, how does that work? Is it kind of, how's it feeding into it? Can you explain to our listeners?
It's sort of it's hard to explain. It gently ramps onto the program, onto the profile, and ramps off. It never digs itself into a tight corner. It will sort of arc its way and do lots of small arcs to get into the corner, rather than just plunging straight in and straight out. And yeah, because it's working with the helix angle of the cutter, the knowledge of what it knows about the spindle type of machine and everything, it's always soft cutting, and we can do overhanging flanges on parts without any concern of vibration.
So effectively, what we're saying here is that we've putting all these elements together. We've not mentioned cutting tools yet, but putting all these elements together, we're putting a stable process together.
Indeed, yeah. And just to touch on the cutting tool slightly, I mean, there's lots of carbide end mills out there, some more premium than others. But we've found so far with SolidCAM, as long as it's in the, it's not the budget type of carbide, you can put it in there, and just changing the braveometer, as we call it, you can easily get nice smooth cutting every time.
What about the tool holders, Chris?
Again, because ironically, the first type of hydraulic holder that we had, that we were trying to do that titanium part, it actually pulled the 16mm end mill out of the holder. So we moved to just an ER32 collet holder, and it actually held better and worked fine. And then we moved to a hydraulic chuck, which was then obviously the far superior tool holding, and that's still working fine for us now. So again, you can hold any tool in any holder, but with my experience of being a tooling rep, I know it's all about the complete package. And like a lot of people don't even believe that coolant bears any effect to what you're doing. Well, that's absolute rubbish. Just the percentage of your cooling. I'm a true believer that you worry about the fine details, and the rest of it will take care of itself. And it's I suppose, in sense, it's people that are running almost like jobbing shops that have a machine, they throw a part in, they quickly knock a few holes out. If you've got high-end machinery that you want high-precision parts, if your setup isn't correct and you don't take the time to get your setup correct, you won't have a high-precision part at the end of it. You'll have a substandard part, and that's, really is the emphasis on having the best possible setup, tooling, work holding, cam packaging machine, and you'll get a quality product at the end of it.
And let's talk about the benefits that you get from that then now. So, I mean, what you've said there, really, you're only as strong as your weakest link, Chris, and you're absolutely spot on. Now, let's address the benefits that you've got from doing just that, Chris. So, we looked at that titanium part as an example, a valve body for the oil and gas industry. Now, Ben, you were involved in the programming of this. Can you tell us, the time savings that were achieved from this strategy, cycle time savings? It's absolutely staggering.
Yeah, I think it was a combination of obviously moving it onto the 5-axis machine, so being able to hit it in just a couple of ops instead of keep turning it over. But again, iMachining played a big part of those time savings. The roughing alone on that component came down from I think it was days, wasn't it, Chris? To about 7 hours.
Yeah.
To rough the entire component out of a solid carbide end mill in titanium. It's quite a good achievement, really.
I think ultimately what that boils down to is competitiveness. From Brafe as a company to be competitive in the UK, but also around the world to start hopefully reshoring work, but also profitability. The business can start to become more profitable. They can start reinvesting in new machines and so on and so forth. But time is money, and the proof is in the pudding from what you guys have achieved. Now, Ben, your software must be continuously evolving with the advancements in these machine tools and the complexity of the components and the new cutting tool strategies. So, as a company, how do you keep up with this?
Yeah, I mean, we're constantly evolving the software. There's always updates coming out. Every major release has some big improvements and some new strategies in there. For instance, 2021, we were all about barrel cutting, and there was a big push on that. We got lots of enhancements in the software for using barrel cutters and the barrel cutting family as well. So as well, when people hear the word barrel cutting, they think instantly 5-axis. We can use lens tools in 3-axis, for cutting what you would generally cut with a ball nose. We can use a lens tool instead. So instead of having let's say a 10mm ball nose, where you've got a 5mm rad on the bottom of there, you could use a 10mm lens tool, so the same size shank, but you could have like a 25, 30, 40mm radius on the bottom. So the step over increases, drastically. So from doing, say, 0.1 step over, you could go up to like 1mm step over. So you're at 90% cycle time savings before you've even looked at the speeds and feeds. We're also the next release is due out soon, which is obviously going to be SolidCAM 2021, and there's some big improvements in machine tool wise there. So sliding heads, we've got some new modules for sliding head. We've got some new functionality in there to support all the features of a sliding head machine. We've also got a new tool table as well. And that's a tool table across the board. So it's for the entire SolidCAM. Easier management of tools. We create assemblies and things now in there. So lots of improvements all the time. Keeping up with that is, it's us really, the resellers around the world, all the engineers feeding back to development, what is needed in the industry. And it's quite refreshing for, from my point of view, it's quite refreshing for the developers to sort of take that on board and listen to what we're telling them and listen to what's out there and what's needed next and how to develop the software really. So yeah, so although it's built and coded by developers, it's also we also have lots of engineers feeding into that development process as well. So it's a good sort of full circle program really.
Yeah, I think that as engineers, we never stop learning, and I think that's why it's such a good career, really. And I think that what you mentioned at the beginning of the podcast is that, we've been around, and even in my sales career, we used to travel the length and breadth of the country, visiting so many different engineering shops, and everyone could be making the same part in a different way. And it's invaluable knowledge because you pick up different bits from each different shop that you go into that you can start implementing within your own facility. And Chris, coming back to you, really, I think that I can't really see a weakness in the process that you've got on that, Rob, for the work you do. I think you've got an absolutely fantastic setup on that, Grob. And I mean, for the listeners really that are looking to improve their manufacturing facility, you can watch the videos that we did at Brafe Engineering Ltd on the MTDCNC website to have a real good look at the setup really and what we're talking about today. But Chris, what advice would you give to engineers that maybe have got barriers to entry in regards to fear of implementation of some of these latest technologies? What will happen to them if they don't invest and try to change and try to kind of move forward? I think that you're a perfect example of someone that's embraced everything.
Yeah, I mean, obviously there's always the financial aspect of what we do, and at the moment for a lot of people things are tough, and some people are doing a lot better than others. We're very, very lucky. We're doing okay. So as always, sales could be better. They could be worse. And we're lucky we invested when we did before the second lockdown hit. And I think the biggest thing is just you can't compromise. You can't cut corners. And a lot of people, they just look for a quick, easy win and cut the corners. And it might work short term. Long term, it's not the right way to go. Long term, you've got to try and get everything aligned correctly. And once you've done it once, it should almost become second nature moving forwards. If you always start cutting corners, you're always going to end up cutting corners, and it's always going to come back and bite you one day. We try and do things properly, professionally, have a good, clean method and process for manufacturing parts, and that's what we've achieved with Rob, the work holding, SolidCAM, and everything that goes with it. And we've aligned ourselves with key partners to make sure that we've got the support that we need to achieve our goals. I know the next challenge that Ben's got from me, he's now got to try and sort out an angle head milling process for me on a couple more titanium parts. So it's very much us stretching our suppliers to get them to grow and develop to our needs as well. So,
yeah. Fantastic, absolutely fantastic. I mean, we're solution providers, aren't we? We're all like looking for a solution. And I've got one final question for you both. I just want a yes or no answer. Without investment in some of these latest technologies, such as the SolidCAM, the grobs, the automation, the work holding, cutting tools, tool holders, can companies survive in this day and age? Ben?
I would say it's quite difficult. You need to stay competitive, and I think the only way to do that is invest in the latest technology, especially going forward now after COVID and everything. Once things start opening up, there's going to be a lot of people, battling for the work, and whoever can produce it quickest and the most efficiently is going to be on top. Really,
I couldn't agree more, Chris.
Yeah, I'll agree. I think the other big key thing to it is the bigger blue chip companies. They want to see this kind of development. They want to see this growth. They want to see, that you're doing things correctly. And when it comes to site audits and that, it's nothing can beat what the good things that you can show them. And yeah, it's all too easy just to sort of sit on your hands and hope it's going to come to you. But you've got to go out there and you've got to fight for it. And you've got to compete just to stay competitive. So.
Well, guys, it's been an absolute pleasure having you on the MTD podcast today. I hope our listeners have enjoyed it, and thank you for listening. And make sure to tune in every Monday. Make sure to download the MTD app from your smartphones to stay in touch. And if you want to contact Chris or Ben, I'm sure they'd be happy to give any advice that you're after. Guys, again, thank you very much for today.
Thank you.
Thank you very much, Joe.
Take care. Until next week, the MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.